Hey everyone, Sean here for Lambda School, and in this video we're going to be talking about the queue data structure now. So the objective of this particular video, as with the others, is to understand how queues work and to start to build up a conceptual mental model in our heads so that later on when we get to the programming part of the sprint, we'll just essentially take that mental concept that we've started to build up and translate that into code. So what exactly is a queue data structure? If we're talking about what a queue is just normally in real life situations, a queue is basically how British people, that's what they refer to as a line. When you're waiting in line at like a movie theater or at DMV or any situation like that, you get into the back of a line and then you wait until everybody in front of you has gone there and taken their turn before you finally get your turn. So the queue data structure essentially just encapsulates this functionality or this ordering, right? So with items that come into a queue, they always get added to the back of the queue first, and then they need to wait in the queue until everything in front is removed first. And so this concept of this ordering is called first in, first out, often abbreviated FIFO, and this is essentially all a queue data structure really provides. So if we were to look at an example queue class and what that might look like, we might have a size counter on the queue, mostly just for convenience, so that it's easy to always know how many items we have in our queue data structure at any point in time. And then additionally, we will need to have some sort of underlying data structure that's actually going to store the elements in our queue, and that it will make it easy for us to facilitate the FIFO ordering that we're trying to achieve with a queue data structure. So with all that being said, there are some questions you're going to want to ask yourself regarding the data structure to better flesh out and conceptualize how a queue works. So first off, maybe think about, what's the opposite of the first in, first out ordering? So think about that a bit, and maybe also think about, what are some data structures that exhibit this particular ordering? Again, also start to think about what data structure or data structures, because there might be more than one correct choice here, but what data structure would you use to easily kind of facilitate the behavior that we're looking to achieve with a queue data structure? And then lastly, another thing to think about might be, when is FIFO ordering useful and when is it not? Lastly, let's look at a few of the pros and cons of queues. So again, as you can see, our explanation of a queue was pretty short, and that is based in large part to the fact that queues are very simple and pretty intuitive to use as well as to implement. So frankly, I think if I gave away any more details as to how the queue data structure works, it would just leave little to the imagination, and it would kind of be like giving you guys too many answers, or maybe making it a little bit too easy. So next up, another pro with queues is that they're very handy when you're looking to serialize data coming in from multiple sources. Basically what this means is, if you can imagine a scenario where you have a bunch of data coming in from multiple sources, for example, maybe you're on a server that's serving multiple clients, that server needs to handle all those requests concurrently. And one way to do that might be to have all those requests come in and get in a queue, or basically to get in a line. And essentially that is what happens with real world situations, right? Like for example, again, if you're going to a bank, a lot of people might be coming to a bank to line up at a teller at any given point in time. It's not just one person coming in an orderly fashion one at a time. People come in to a bank as they so choose, and so the whole point of a queue or of a line is to basically serialize or add some sort of ordering to data when there are multiple sources of data coming in at any one point in time to essentially invoke some sort of ordering on the data. And then kind of the main con of queues is that, again, they basically just perform what we've been talking about. They are simply used to serialize data and achieve this FIFO ordering that we've been talking about. So you can imagine then that queues really cannot be used for anything else, right? They're not general purpose at all in and of themselves, unlike arrays or maybe perhaps even linked lists. Those particular data structures are much more general and can perform multiple functions as opposed to a queue data structure. So that's it for talking about the queue data structure as far as a brief overview goes. Please take some time to think about the questions that we've asked so far in the video, come up with questions of your own, write them down so that when we get to the live lecture, you'll be able to ask those to the instructor as well as your classmates so that you can get a better understanding of how this particular data structure works. Thanks.